On this call, we've got a complaint about system not keeping up with the thermostat. It is a 3-ton heat pump system, Goodman Manufacturing, and this is our culprit. These fusible links break for several different reasons, but primarily because the heat in the electric heat compartment is excessive. So what we're going to do is remove these and install 2 new ones and then test the system out. Alright, so we got the new fusible links in place, and we'll put the heat kit back in and run the auxiliary heat to see if there's any particular reason that is noticeable as to why the heat fusible links had failed. So we know that the auxiliary or electric heat is working again by the amp draw. We got 38.7 amps on the heat strips. We've got a 69-degree return and a 97.5 degree supply, 98, which is a 30-degree temperature rise off of those heat strips. If we go into the quick tests for iManifold, we can go to airflow tests, and the electric heat temperature rise method. We'll input just a 240 nominal voltage for fun, and then I think it was 38.7. We'll capture active data, and the way it's running at the moment, we're only putting out about 1,000 CFM. Something that is usually not seen is an actual glow from the heat strips in the cabinet. And through that hole there, you can see that we've got an orange glow. Right now we're actually on low fan speed. So I'm going to swap fan speeds and see what that does. Typically a low fan speed on a 3-ton system is not acceptable. Most systems low speed is not what you're looking for. So I'm going to pull the fan tap and see what changes. Okay, I've got it on high speed, and I do realize that with the air handler here and my temperature sensor there, I'm definitely getting a little bit of radiant heating temperature rise, but 200 C or 2 tons worth of airflow is definitely insufficient. So what I'm going to do is see what the filters look like and see if that could be causing some of our restriction and aggravating the situation. Can you hear that? Because that's part of our problem, I'm positive. Registers upstairs are mostly, if not all, closed. Okay, so I went through and opened up all the registers on the 2nd floor, and at this point I would probably be willing to accept that the radiant heat off of the heat kit in the plenum would definitely be enough, in my opinion, to drop us that 160 CFM. I'd say we're probably a good 4 degrees maybe off of radiant heat. Wouldn't surprise me anyway, but that's definitely much better than it was. We still have some glow glow there, and that is not terribly exciting. I think we're much closer to the space where we need to be now than we were before. That's not good at all. 6-degree temperature split with a 19 psi suction. As much as I hate to do it, this customer's looking at some additional trouble to be dealt with. Alright, so as a wrap-up, the leak detection down near the service valves appears to be simply residual refrigerant from where I was adding refrigerant. I popped the top on the unit and leak searched from the inside, and I didn't get any indication except for when I went penetrating through the liquid line and suction line service connection, pipe penetration. I typically don't care to do leak searches at the same time that I add refrigerant because of that and the potential to get a false positive because of residual refrigerant gas. But got the system up and running, discussed the situation with the customer, and we're pretty much going to wait and see how long it takes for the system to leak down refrigerant because the warranty's expired now anyway. Came out to be a pretty good service ticket in that regard, but appreciate you watching. Like, subscribe, comment, and share, and we'll see you on the next video. Peace.